Welcome to the explainer. Okay, so every time you step up to a sink, turn on the tap, and lather up your hands, you're actually kicking off this absolutely fascinating microscopic chain reaction. Today, we're diving into the molecular mechanics of soap. Because what seems like honestly the most mundane daily task in the world is quite literally a masterclass in chemical engineering. And the craziest part? It's happening right there on the surface of your skin.
Let's start with a really relatable everyday frustration. Have you ever tried to wash greasy, dirty hands with just plain water? Think about working out in the garage, fixing a really greasy bicycle chain, eating oily pizza, or, trying to scrub out that one stubborn plastic Tupperware container. You can scrub and rinse all you want under that faucet, but the water just beads up and rolls right off the grease. It's so incredibly frustrating, right? You're left with this slick, sticky feeling, and the dirt doesn't budge an inch.
Section 1. The oil and water problem. Why water alone fails.
So this everyday failure really just boils down to fundamental chemistry. Oil and water, they simply do not mix. Think of a bottle of oil and vinegar salad dressing. No matter how hard you shake it up, they always separate. Water molecules are highly social with each other, but they totally ignore oils. It's kind of like trying to force the wrong sides of two kitchen magnets together. They just push each other away. And on the flip side, grease acts like a sticky glue that traps dirt directly onto your skin. Because of this massive chemical incompatibility, pouring water over greasy hands is basically like pouring water over a freshly waxed car. It just slides right off without actually cleaning a thing.
Section 2. Anatomy of a soap molecule. Meet the diplomat.
Enter the hero of our story, the simple soap molecule. It acts as the ultimate microscopic diplomat, stepping right in between these stubborn substances and forcing the oil and the water to shake hands. To understand how it does this, think of its basic anatomy sort of like a microscopic tadpole.
On one end, you have the hydrophilic head. Now, hydrophilic literally translates to water-loving. This part of the molecule is deeply chemically attracted to water. It wants to dive straight into the stream from your faucet, much like a dry sponge eagerly soaking up a spill on your kitchen counter.
But what's really interesting here is the exact opposite end of that same molecule, which is the hydrophobic tail. This is the water-fearing end. It's desperately trying to escape the water, and because of that, it absolutely loves to bond with oil and grease. This unique split personality structure, that is soap's critical secret weapon. Because it has one side that loves water and one side that loves oil, it completely bridges the gap between the stubborn grease on your hands and the water pouring out of your faucet.
Section 3. The microscopic rescue team. Springing into action.
So the second you create that nice soapy lather, thousands of these dual-natured molecules hit the grease and instantly spring into action. The oil-loving tails burrow deep down into the grime just to escape the surrounding water. They act almost like microscopic crowbars, prying the grease right off your skin. Simultaneously, their water-loving heads point outward to stay in contact with the water. Together, they snap into this highly organized spherical structure called the micelle. Just imagine this micelle as a perfectly engineered microscopic trash bag. The dirt gets caught dead center, totally surrounded and locked in by a protective outward-facing shell of soap.
So the crucial point here is seeing how this microscopic trap gets your hands clean through a beautifully simple, highly coordinated three-step sequence. Step 1, the hydrophobic tails reach in and grab tightly onto the grease. Step 2, the outward-facing hydrophilic heads hold tight to the flowing tap water. Step 3, together they pull. It is exactly like a tiny, coordinated tug-of-war team. Because the entire outside of this micelle structure loves water, the flow from your tap can effortlessly sweep the whole shebang, grease, dirt, and all, right down the drain. The enemy has been grabbed, bagged up, and completely dragged away.
Section 4. Dismantling germs and viruses. The invisible battle. Now this tiny rescue team isn't just moving harmless dirt around. Soap is actually a wildly potent weapon against microscopic pathogens. To understand why soap is so deadly to germs, we have to look at the germs themselves. You see, many dangerous viruses and bacteria are protected by an outer shell made of lipids, and fundamentally, that's just fat. Think of it like the germ is wearing a greasy protective coat of armor. It absolutely relies on this fatty shell to hold its structure together so it can infect its host.
And this brings us to soap's ultimate finishing move. Remember that hydrophobic, oil-loving tail we talked about? Well, it is incredibly drawn to the fat in the germ's outer shell. So the tail wedges directly into that lipid armor, literally acting like a wedge driven into a piece of firewood. It pries the shell apart, completely disrupts the structure, and dismantles the germ right there on your hands. It's kind of like popping a fragile water balloon with a pin. It violently destroys the threat, leaving absolutely no way for the germ to survive.
Section 5. Science that Saves Lives. The Historical Context.
To really appreciate this invisible battle, we kind of have to look back at the pioneering scientists who first figured out how these molecular films even operate. A major pioneer in this was Irving Langmuir. His groundbreaking study of surface chemistry gave us the exact blueprints to understand how oils, water, and molecules interact right at the surface level. It was scientists like Langmuir who decoded this foundational chemistry that is quietly keeping us clean and safe every single day.
When you zoom back out from all this intense microscopic action and you're just standing there looking at your perfectly clean hands under a running tap, it's honestly a pretty humbling realization. Soap is such an ordinary, everyday item. We buy it at the grocery store without a second thought, right? Yet its fundamental chemistry is powerful enough to change global public health. This incredibly simple, beautifully engineered molecular reaction has saved countless lives throughout human history, quietly and effectively protecting us, one tiny micelle at a time.
Which brings us to the end of our explainer today, leaving us with a truly fascinating thought to chew on. If a simple, almost completely overlooked soap molecule, something sitting right there on the counter in literally every single kitchen and bathroom on Earth, can perform such incredible chemical feats and completely transform public health, well, what other microscopic miracles are quietly hiding in plain sight in your daily routine? I really hope this has changed the way you look at something as simple as washing your hands. Keep questioning the ordinary, keep learning, and I'll catch you in the next explainer.